All right. Thank you, everybody, for joining us in the room and hopefully some people online as well. I would like to start by acknowledging the traditional owners of the land we live and do our research. And I'm very pleased today to have three speakers visiting the FAIMS school that are going to present on a very exciting project, I think, that will potentially make our life easy for those that make field work. So I'm not going to spoil the talk, but they'll say more about it. But first, I would like to introduce the speakers, of course. We have first Professor Sean Ross. He's a professor of history and archaeology and the director of strategy initiatives, digitally enabled research at the Macquarie University. He will be joined by Penny Crook, that is a historical archaeologist and part-time research fellow in the Department of History and Archaeology in the Macquarie University, and also Brian Bolsan-Stanton, is that the correct?
Yep.
More or less, who is also a PhD. He did the PhD in the University of New South Wales, Australia, and is a solution architect for digital humanities at the Macquarie University Faculty of Arts. All right, so with further ado, I'll give the room for Sean.
Thanks, Marta, and thanks for inviting us down to give this talk. So what we're going to do today is give a bit of an introduction to the software that we've been working on, as we realized yesterday when we were updating these slides, for over 10 years now, and what where we've come from, what we've learned from doing that, and what we're doing now. And this is software for field data collection, which, when we started this we first started talking about it probably in 2011 and got our first funding and got off the ground in 2012. But I didn't think we'd be still doing this in 10 years. I thought that this was a problem that would be, solved by a generous grant at the time from Nectar, now since absorbed into the Australian Research Data Commons. I thought it would be a problem that would get solved by a solution that was developed with a grant, and it turns out that field work is much more entailed than that. And so I thought maybe we'd talk a little bit about our journey and where we're at now. So as I mentioned, we started off really in 2012, and we started in archaeology. And our idea was, archaeologists, we do different things, but there's a finite number of them, and that if we built data loggers to handle excavations based on stratigraphic units, standard sort of approach to excavation used around. It's not the only one, but it's a solution that would solve a lot of problems. If we did that, and for the kind of surface survey that's commonly done in the Mediterranean and Mesoamerica, and then maybe another one for the kind of surface survey that tends to be done in Australia and some other parts of the world, and we did ceramics, we did lithics, that, we did 5 or 6 of these data loggers. We could cover most of the workflows that archaeologists use. And we were thinking about this because a couple of us who started it had just come off of finishing 4 years of field work funded by an ARC linkage project that we'd done in Bulgaria, surface surveys, landscape archaeology of surface survey, and we had literally sort of thousands of, survey units where, in archaeology, we line students up, say 15 meters across, march them across plowed, agricultural fields in Bulgaria, and they count pot shards and other artifacts that they find. And we had thousands of these survey units with counts, with metadata about environmental and agricultural context and other things. And we tried to use the best available tools at the time, which were mostly Esri, ArcGIS stuff, ArcPad and ArcGIS desktop, and we're really, really dissatisfied with it. And we're like, okay, we need tools that are built for this job, not jury rigging, commercial solutions that are made for other things. So coming out of that, we went into this, and we got 40-odd archaeologists and 20-odd technologists into a room. We said, okay, we just need to work out for surface survey, for excavation, for artifacts, etc., what we want to record, and we'll make a system that does it. Budget, we're going to build this software and we're going to do it right, test it properly, all that, do our requirements gathering, business analysis, all this. And I love this picture because we started talking about standards, like how do you measure a lithic, and everybody kind of looks at each other like this. Had a big argument. One person stormed out and never spoke with us again. By the end of this workshop, it was clear that we couldn't make like a series of data loggers. And the project suddenly became sort of much bigger, which was to make a generalized platform that lets the user specify the data model and the workflow, and then instantiate that as a mobile application. And there's some reasons, and I'll try not to go too big. Like, so we started researching this problem, and lo and behold, we're not the only ones who've ever faced this. And so there's some work in archaeology and also some work in ecology, largely by a scholar named Catherine Borgman. And there's some things that are special about field research. And the first one is that it's sort of I guess an archetypical, what Eric Hansa, an archaeologist, calls a small science domain, as opposed to the big science domain, in the sense that everybody's focused on big data and big science, CERN and and the gravitational wave thing and the square kilometer array and all of this. But most research in the social sciences, humanities, and in the sciences is this smaller scale research, which doesn't mean it's easier. It's just hard in different ways. It's hard in ways like that, the approaches and the methods are much more diverse. The questions being asked as well. One of the big ones that trips up other solutions, field data capture, is our data is so heterogeneous that we'll go out and we're collecting geospatial data, structured data, images, sometimes video and audio, as well as sort of free text, and we need to annotate everything, and we need to keep the metadata under control. And so handling multimedia is a big deal, and really pulling together, for example, geospatial and structured data, because we sort of fluidly move back and forth between those things. And if you look at most of the tools that are available, commercial or open source tools that are available for field data collection, they're either map driven or they're data driven, and it's quite hard. And again, not to look, I'm an Esri user. I'm not like trying to have a go at Esri too much, but if you look at them, this is even reflected in the way they've got field maps and survey 1, 2, 3, and then one's for geospatial and one's for more structured data. And there are reasons why they do. This isn't sort of arbitrary. It's not malicious. It's not. There are reasons to do that. It's quite difficult to do both things well, as we've found out. So the heterogeneous data, one of the big things is how much of your data and how much of the infrastructure. And this was Boardman's main, one of her main contributions. How much of that is emergent from the field work, that there's an element of serendipity in field work, that you don't always know when you go out exactly what you're going to encounter. And it almost always takes I was thinking field seasons because I'm an archaeologist, or, field trips or whatever you want to call them. It takes a couple of times to go out and do that, to figure out what your recording system really needs to look like, what your data is going to look like. So it's got this emergent property to it. And in many of our disciplines, I know this is changing in the bushfire, area, that there are major national initiatives to federate your data and bring your data into alignment with standards, applied vocabularies. But compared to astronomy, say, most fieldwork disciplines are a bit behind in the standardization of data as well. There's a relative lack of standards. And again, until, and this is changing in bushfires, particularly after the last, 2019, 2020, but in many of our disciplines compared to astronomy, again, some of the big science, we're underfunded compared to those. So, and have limited infrastructure. And it's hard to convince funding agencies, to reliably fund our infrastructure. And all of these things are getting harder because we've got in our fieldwork discipline these small data problems, but now we're also starting to get the big data problems grafted on top of that as we start employing approaches like photogrammetry. I did 10 days of photogrammetry a year and a half ago, and made almost 4 terabytes of data in 10 days. And and that was the first time I'd ever done it. I did it kind of under the I'm a technical photographer as a side thing, but under the instructionist, I'm no specialist in this. But you know, you can really produce large amounts of data, especially as DSLRs and mirrorless interchangeable lens cameras get to have bigger and bigger sensors, and you can do more and more with it. But that the size of that data and the number of files you're dealing with is starting to get really challenging. And you know, because of sort of this combination of things, the solutions that we have in our they tend to be quite ad hoc. A certain amount of paper, a certain amount of Excel, some ArcGIS, something to handle multimedia, Evernote or whatever to do longhand note. And you know, that's been a pattern that really emerged, you know, probably in the couple of years after mobile devices became widely available, after the iPad and, you know, iPhone came out, and then Android slightly later than that. You know, and we've been quite slow to move beyond those sort of ad hoc solutions like that, which can build up quite a bit of a backlog of digitization and data reconciliation. And what this leads to, I mean, this is, I think, the worst in archaeology, but you see it in other things, is you finish your field work, and I'm guilty as charged with this. We have not published our final data set from our field work that ended in 2011, 2012, that you get a mass of data. Some of it's on paper, some of it's digital. The digital stuff is not all clean and consistent. And, you know, I have reviewed archaeological publications from digs that happened 50 years ago, and they've just been published. You know, it's after all of the, you know, the excavators are all dead, and, you know, and everyone's trying to reconstruct what happened in the data. That there's quite a delay and an impediment to our research because we don't have analysis ready data when we come home from you know, from the field. Spent a little bit longer on that, so I'll skip over a few things here. Data lifecycle, we're focusing really on I think what you know, where the biggest need is and what we do best, and we're not trying to sort of, you know, conquer all aspects of this. That we're focusing quite specifically on the collection and capture part of the data lifecycle. There are quite mature tools in a lot of fieldwork disciplines for like data repositories for publication and archiving of data at the end. And there are, you know, now, you know, moderately mature tools like around sort of research, virtual research environments that, you know, let you work collaboratively, you know, online if that fits your workflow. But I still think even 10 years in that the collection and capture part of the data lifecycle is underdeveloped. So what have we actually done then? So from 2012 until until next year. Yeah, until next year. This is still going on, and until about 2018, 2019, we developed a piece of software that was an Android-only mobile application that ran on that used totally 2012 technology, you know, relational database that was beaten into submission to make it do what we wanted it to do. Geospatial tools were available at the time, you know, that let you specify your data schema with an XML file, specify your workflow and your user interface with an XML file, run those files through an interpreter, and it would generate you a mobile application. So we worked on that for many years. We tried to build in a number of research-specific features that I'll talk about. We made it generalized in this way and this was one of the hardest things to explain about it. Out of the box, it doesn't do anything, right? You must specify what you're collecting. It was an app generator, not an app. So, and all of this we developed open source and focused on the early part. So as far as research specific goes, we tried to bring together the different kinds of data that we collect. We built, it had mobile GIS with layer management, points, lines, polygons, make them, edit them, show, have, legacy, be able to load legacy data, into it. We allowed map-driven workflows or data-driven workflows or any combination thereof of flipping back and forth, and that would all be bound tightly into a single record. Other things like, controlled vocabularies are everything when it comes to making your data consistent. So we had all sorts of ways of implementing controlled vocabularies, like using picture dictionaries. So, that you didn't have to help guide novices, students during field work, whatever, or just jog people's memories when they were trying to select things. Hierarchical drop down where you could go through a hierarchy. Including through a process like one that was commonly used was the U.S. Geological Survey soil classification, where you make it into a ball and get it wet, and we'd step you through that process and tell you at the end that you've got sandy loam, that kind of thing. Lots of attention. We predate the FAIR data standards, but we were quite engaged with open link data at the time. So the ability to take all of these controlled vocabularies and map them to a shared vocabulary by embedding a URI, a stable URI, a persistent URL into the vocabulary, so that you could sort of define a concept by saying, this local concept is equal to that online, this shared scientific vocabulary. We didn't see a lot of uptake with that, I have to say. We were quite happy with it, and but it was hard to get researchers to sort of invest the time to do these mappings of their local vocabularies. See if what I've forgotten. Oh, and I've been forgetting one of the important. So all of this works totally offline too. That was another thing that this sort of distinguishes that our approach is that you can take your device, and once that you've set up the customization on all of your devices, you can go collect data offline as much as you want. When you come back and you hit a network, then everything syncs, and it just syncs. I remember what a hassle it was to sync ArcGIS data, and judging from, and even now syncing like ArcGIS maps, field maps, and 123 data, survey 123 data is not trivial. This just syncs when you come back and hit a network, and it was agnostic, or it's agnostic about whether you use an online server or a local server. So we had deployments where they had a Pelican case with a small industrial computer or NUC in it, an Intel NUC, it's a small computer, an uninterruptible power supply, and some networking gear, and they could go, and I've used it myself this way, go out in the middle of nowhere, record for weeks at a time, and it'll sync and it'll sync using this local network, and you could deploy and modify the system using the local network, which is again something, and I sound like I'm picking on ArcGIS, maybe I'm a little bit, but like there are limits to what you can do when you're offline with other tools. So what else is really we keep a very sort of bulletproof data history. We've built this, Brian built this around an append-only data store. So data is, when you delete something or you edit something, nothing is ever deleted or changed. It's, it's added as a new row in the data. So you see who did what, when, and that's just baked into the whole application. Mobile GIS, I've already mentioned. We could connect to devices and external sensors. Bluetooth GPSs were the most common there, but we also connected to various sort of digital calipers and other random things. Bluetooth printers, barcode scanners, those kinds. It was meant to be a platform that could be extended. One of the most popular things that we did was enable you to take, if you've got a bunch of photographs and they're connected to the record, either because you took them on your on your device, or because you used the server to connect DSLR photos to a record, you could take all of those and rename them based on the content of the record, and you could write the whatever you wanted from the record up to and including the entire content of the record to the metadata of the photo, so that if somebody got the photo, they could get all the data was tied to that, and the photo was connected to the record as well. Lots of validation and automation. We had a lot of some projects really worked on optimizing it. Cyro Geochemistry, they were using they were doing a helicopter geochemical survey, so it was like $4,000 an hour to use the helicopter, and they optimized this to death until they got every second off of it, and it saved them about 40% of their field time, and then some additional time in in data cleaning and reconciliation. So they figured that they saved a lot of money, by doing that kind of using automation validation. I can talk more about that later if you want. We did a multilingual user interface, so you could set it up so the UI was and the recording was done in different languages, and we had it used in China, we used it in Bulgaria, worked across scripts. I think looking at these, the final thing I'll mention is we were very serious about getting metadata at the level of the whole project, at the level of the record in the project, and then also at the level of individual fields. And in it, that they all had an annotation attached to them. So this is sort of like the margins of the paper form, or flipping it over and writing on the back. There was a place to do that. And we did that because we thought it would be useful. And it also later, when there were sort of criticisms of digital recording, that it's too constraining and it turns field workers into little machines that don't think about what they're doing, we could say, well, we've pretty much captured the flexibility, the ability to reflect on what you're doing that you can do on paper. And we didn't think that criticism really held up. This could be and I'll wrap up so that we can tell you more about our new system. But this was generalized. We started in archaeology, but most of our uptake now is in geoscience, some ecology projects, oral history, ethnography. I think with the new system, it might be something that'd be of interest in in bushfire work. I mean, I think a number of your workflows are similar to whether it's to do with remote sensing, doing training data sets for machine learning approaches. These are all things that we've encountered in quality assurance for machine learning approaches, crowdsourcing stuff. These are things that we've seen in other disciplines, as well as sort of more routine mapping, just going out and mapping things, because sometimes there is no substitute for getting out into the field and mapping, what's there directly, visually. So we're still used by archaeologists, but I'd say that's a minority of our work now. So everything's open source. Our new software is Apache. Our old one was GPL v3. Our new software is Apache. And yeah, in the end, for 2.6, from 2014 was really when we had our first production release until now. We've customized it about 70 times, and with the XML customization, I have to say, most with two exceptions, maybe three, everybody came to us and paid us a small amount to to do the customization for them. And we ran as an open source consultancy. Penny will talk more later about what our business model is going forward, but in the past we've run partly as a grant funded research infrastructure project, supplemented by an open source consultancy. We know that at least 54 of those workflows were deployed by something over 40 projects. And we've had tens of thousands of hours logged on the platform now. Yeah, wide range: avian ecology, oral history, oyster reef monitoring, and then archaeology all over the world. That's about where that's the FAIMS 2.6 story. 2.6, Penny, did you want me to talk about what the problems with 2.6 were, or like why we wound it down, or do you want me to just hand over to you now?
We're handing over to Brian, but if you could just do a quick intro to the ARDC platform.
Okay, sure.
Because these are our partners.
Yeah, so these are partners. So 2.6, the last version of our old software, it got the end of life in about 20 we could see the writing on the wall in 2017. By 2018, 2019, it was really it was getting to be end of life. We couldn't support it anymore. We knew we needed to rebuild it. So we went through the Cyro on Prime program, interviewed a bunch of people about what they want with it, what were the problems, like why did people decide not to, adopt it if they didn't, and identified that we needed to build something in a modern stack that was cross-platform. The fact we were Android only was a real killer, that could be customized in a self-service sort of way, not with XML, but with a user interface, and that had better interoperability, like what we determined shorthand a round trip. We could always export to wherever you want, but it was quite difficult to take something that we collected, go modify that in ArcGIS or Excel or OpenRefine or whatever, and then import it back for further field work. And so completing that circle, not just making it a one-way out, but completing that circle was the other thing that came up. We took that knowledge, applied for an ARDC Platforms Project grant in late 2019. We found out we won it and started that redevelopment in 2020 with this group of partners, which includes ANU. So that's and now I'll turn over to Brian and talk about.
Hello. That's where we were. With the help of the ARDC and CSIRO, we've now developed a brand new code base for data collection in a cross-platform way. So this includes browser, this includes iOS, and this includes Android. It turns out we were correct in 2012 to just focus on Android, because this project was significantly more complicated by virtue of the breadth of the thing. We are bound and determined not to keep ourselves as the gatekeepers to data collection workflows. And so rather than an A-shaped graph where very few people can just rock up from the street and do the thing, and then some number of people can do small software development projects with us, but the program itself is untouchable because of the age of the program. For FAIMS 3, it's going to be U-shaped, where we are anticipating most of our users can self-serve eventually. Very few customizations mediated by us, save for those people who want to give us their workflows and have us enter the data because they are time poor but resource rich. And then more major changes to the app so that everyone can benefit. The other thing that we were focusing on is, from the start, rather than an abomination of a SQL-like database, where if I was very, very, very careful indeed, could write to it, we have a way of saying, yes, if you have, and this is from yesterday, if you have a bunch of soil plots with crops in them that have a very specific set of characteristics, yeah, sure, import them into the app to enable observations. Yes, have external systems load data in to support your experiments, because sometimes you can't just go out into the field with a blank slate. More to the point, when your undergraduates are done with the day of the field, it's quite useful to sit down and go, so what exactly have you entered today? And then to adjust this and edit this, and then put that data back in. And so the idea of cross-platform, the idea of that round trip, that ingest of extant data, and the idea of you don't have to come to us for good data collection design was what inspired our most recent development. So these are some screenshots. As you can see, we actually have a graphical user interface to create notebooks. And so we're calling these instantiated workflows notebooks. And I've almost trained myself out of the old language which I'm not going to even mention because if I mention it, my brain will go clunk. So you can create notebooks. The notebooks allow you to create a structure. And the way to think about it is a notebook is your observational container. A notebook will have one or more forms that is a structured, ordered series of fields that can do structured data, relational data, and I'll get to that in a second, multimedia data and geospatial data as part of a workflow that is exported at the same time, at the same priority. You don't have one of those better than the other. So you have your structured data, you have controlled vocabularies so that you don't get 14 different words for the same kind of dirt. Ask me how I know that one. We have multimedia so that we can encourage our undergraduates to snap aggressively. Because I was talking to you, we have a groundwater project where I'm like, so what photos you want to take? And they're like, oh, well, we're doing some vegetation sampling, so we'll do a tree. I'm like, really? So just the tree? Oh, well, we should probably do the tree and then do the roots and then do the leaves. And so now we have 7 different photo fields labeled as such so that you can say, this is the large landscape. This is the tree in the landscape. This is how the tree interacts with the groundwater. This is a leaf of the tree so we can actually figure out what sort of tree it is. And by having that as a first class data collection workflow, you can actually be useful rather than having 30,000 DSLR photos and you're trying to track which photo goes to what part of your record. Turns out undergraduates don't really track that very well. Yes, I'm picking on undergraduates because I don't see any here. And then with your form, that is one constrained observation in whatever format you want. So whatever order you want, whatever labels you want, whatever fields you want, it's there. For convenience, forms are broken up into views so that you can quickly skip to, oh, I'm doing my chemistry sampling now, or I'm doing my well bore depth now, but they're all part of the same record. However, a notebook will usually have more than one form, because it turns out when we're in the field, we want to collect more than one thing. And we don't want to constrain the same thing into one universal form, because that makes the complexity and the utility of that form far worse. Relational data. One of the major things that we've found is that research data needs to be able to relate to other research data. See Form 3. And in archaeological sense, we have above, below, and abutting. So you're describing the physical relationship of bricks in a wall to other bricks in a wall through references. A, that's really hard. B, that's really complicated. And C, very few commercial workflows that we have seen cater to our specific needs in that way. Beyond relationships, we have hierarchies. So when you're collecting data, I'm at this site. Great, I've got my water sampling in. I need to take water samples every 2 minutes until the flow stabilizes and choose the right water sample. We have a hierarchy. So you can say this water sample has subsamples. Collect, 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 choose. And those are related automatically to the parent sample, so that you're not digging around trying to figure stuff out. FAIMS 2 will die soon, I hope. We are currently supporting legacy users, and those legacy users who are still using the app are deeply protective of their customizations, because that's the trade-off we made, right? In our previous thing, we could make every little change just right to suit your need. That was time expensive, but when we got that right, oh, they loved it. They loved it so. Doesn't scale. And so now we are BYO data set and not really doing that perfect tweaking for the end users. We've done there's a commercialization approach, Cyro on Prime, where we actually had to speak to our end users. We actually had to go up to someone and say, so what do you want out of a data collection system? Turns out that was actually very useful because it allowed us to focus our development efforts on what they wanted rather than what we thought that they wanted. We submitted a high-level design for FAIMS 3 to the US Geological Service and won a small prize, and convinced our colleagues at the ARDC to co-invest in this release. And we just finished our final development cycle for this co-investment. And so we are, in a somewhat ironic turn of events, back to where we started, supporting bespoke deployments of FAIMS 3, because our major infrastructure, we focused on the app itself rather than the supporting infrastructure. So, diagrams for capacity. Now I'm looking at it on screen. Effectively, the technology that we're using, and I'm mindful that we actually want to do a demo, is Node. We're using JavaScript. And so the way we're able to compile to multiple platforms is to have a central JavaScript code base that gets turned into native installable applications on Android and on iOS. Getting a sense of the audience, I'm not going to go into a huge amount of detail here. Happy to chat later. In short, offline fieldwork has always been central to our design. That you're not disadvantaged when working offline, that we expect you to work offline. And that sort of offline first design methodology is what differentiates us from many of our competitors. Because what I tell people is that if you're working in a lab, right, if you have good internet in your lab, which is not always true of all universities, don't use this. This problem of good data, custom data collection has been solved beautifully so long as you're online. Our niche is the offline space so that you can go offline, see, create, edit, and delete data. And it's those last bits that are the most important, because many offline data collectors allow you to collect, but never see and never edit while offline. We also have an advanced conflict resolution so that when your field supervisor is busy correcting data and an undergraduate is busy having opinions, it is possible to see the changes to the same record and choose which individual was correct, the person at the trench or the field supervisor. 50-50 split. We also have to focus on real user management and security. I remember going to my colleagues and saying, "What's your threat model?" And they looked at me. What? Threat model? Oh, you mean like other archaeologists wanting our data? Oh, that was a fun conversation. Now in 2022, I can no longer rely on saying, yes, if you want security, physically pick up the box that your server is in and disconnect it from the internet. And so we have a much more sophisticated user management layer, and we are supporting more interoperability from the start. Stuff happened. We got money. We spent the money on development. Story of software development. It's more expensive than you think, even when you think it's too expensive. One thing to note is beyond the ARDC, we were generously supported by CSIRO, the ANSYS project at CSIRO, Australian National Soils Information System project, Black Mountain, to support the pilot soils monitoring incentives program for soils sample data collection. And so we were interrupted in the middle of our major development to do major development to support them. And so things have been a little bit topsy-turvy, but much to our benefit because it allowed us to have significantly more development time. And so now my colleague Penny Crook, Dr. Penny Crook, will tell us about where we will be going, and time permitting,
Yes.
I will try to do a live demo and data modeling.
Thank you, Brian. So I will go through this fairly quickly so that we do have some time for the demo. It isn't the typical part of a research presentation to be talking about commercialization pathways, but it's consuming a lot of our energy at the moment. And it's also really important for even average users to understand what goes on in managing research infrastructure, because it takes a lot of time and effort to keep the lights on for a software project. So we'll just talk through some of the approaches we've been taking. So as both Sean and Brian have mentioned, our original model with FAIMS 26 was this project-based open source consultancy where if you had an ARC grant or if you were a small business, you had a workflow, you come to us, we design this beautiful workflow for you and really meet your needs and then send you on your way. It turns out that that is not a scalable way to maintain the software in the long run. It was a big burden on our institution, on Macquarie, to be funding us in our spare time, to be taking care of the code, managing updates when there are crises, all the rest of it. We needed a broader income base to support their software and also do feature enhancement. And in order to do that, you need a much bigger user pool, and we had to change the way we approach things. So we had two parts. One was a not-for-profit pathway, which we were dissuaded from because that has some risks in terms of cash flow and also reliability for some users to be relying on a non-profit organisation. And through the CSIRO On Prime program that we've mentioned, we were encouraged to pursue a commercial pathway. So focus on software as a service, as an ongoing service, rather than these bespoke design projects, and then also pursue commercial open source software. So we remain committed to open source, open access data and also open source software. We want to make sure that there is always a free and fair way to access our code, and it's all on GitHub. If anyone has the energy and resources to maintain their own service, Brian's looking rather upset as I say that. If you have the skills and capacity to do that, and you're willing to take on that burden of the maintenance of your data, please go and use the software open source. If you don't have the resources or time to do that, we would like to provide the hosting services so that we can take care of that stuff. We can do it at scale, and you can focus on your own research. So that's the approach that we've been taking. So this commercial approach, or sustainability through commercialization, was a core part of the ARDC project. Our major milestones were business plans and value proposition statements, and just, this is what we spend our time on, doing business canvases and, working out how to do a software startup. We established our business, which was the Electronic Field Notes Proprietary Limited Company, in 2020. Macquarie is a almost 20% stakeholder in the business, so it's a institution-based commercial entity. Part of the ARDC was also having a business advisory group who have been giving us excellent feedback on branding and a whole range of different approaches, pricing tiers, how we approach the market. We have agreed on a new name for the tool, which will be officially launched next year. That is Fieldmark, so it will no longer be FAIMS 3, it'll be Fieldmark. We're working on branding packages and new colours and all the rest of that now. We are still finalising our agreement with Macquarie as part of this commercial spin-up. It has taken almost 2 years. We're almost there. We have an in-principle agreement, and we hope to resolve that quite soon. So that's the sort of organisation going forward. Our ARDC project officially wraps up in March next year. We're at the tail end of funding and work and all of the effort there. So we're looking towards the future. We have small amounts of money from our original consulting projects to keep the lights on for a couple of months next year. We're otherwise looking at a whole new range of funding opportunities through accelerating commercialization. There's a whole lot of schemes and grants that can support us in that space. So we're trying to get the underlying funding to keep us going until we can build up a customer base and get that shared cost going across the board. Our focus for next year will be on automating deployments for the software that we currently have, doing some hardening, getting it all quite solid. Then we'd be looking at new features from 2024 that we would actually have the resources to be focusing on that. We've already started meeting with a bunch of new users, including yesterday. It's one of the reasons we were down here, and we're getting a nice long fat list of things that users that weren't part of the original CSIRO Prime program and who have new and different needs. So we're building up a lovely list of things to do for next year and beyond. And this, of course, is bringing us into new domains. So we've got an opportunity to get some funding through the Bushfire Commercialisation Fund in New South Wales. And we've had lots of discussions with different entities about bushfire-related data collection. And that's one of the reasons that's brought us here today. So I'm going to leave this slide up briefly, and then we're going to do a bit of a demo. And if we have time, do some data modeling if we have scope for it.
Oh, stay up here. And why don't we start with an opportunity to answer questions before we go into our live demo? Because I have yes.
I think this is a great idea, and it actually improves the quality of data a lot just by organizing it.
Yes.
As you said, like a lot of detail gets lost. But because it's offline, and when you collect new data, is that stored on the device that you're collecting on? So is it limited by memory issues on the device, or yeah.
So because I know we're being recorded, the question was, how does offline impact data collection, and are there memory issues on the device? Yes. Okay. It turns out that small devices are small, and when we're taking 7, 8, 10 pictures per record, that adds up quickly. On the other hand, I had some of my students collect 1,000 records and take a photo per record, and it came out to about 2.5 gigs. So long as you have a good, modern, new device, you're pretty much good. The trick is there are some techniques that you may want to engage in if you have a multimedia heavy workflow. If you don't have a multimedia heavy workflow, it's a routing error. It just, and the major trick is we have a toggle to choose whether or not you download everyone else's photos to your device. Don't do that.
So, thank you. Another question was, can you integrate data from other devices straight into the platform, or do you have to, like, if you had plugged in a spectrometer to your device, then could you record that data?
Yes, star. Give us money.
Sure.
So effectively, we've designed that capability in, but each new data source will require integration effort, because unfortunately, there is no common data protocol across many devices. In principle, we can do that. I have some ideas of how to do that. I've written some code for the pilot soils monitoring people to write data to records. And right now, so long as you are attaching data or editing data in a record, I could probably do that for you in about a day. Don't hold me to that, please. But yes, like the
recorded.
Oh, great. I shouldn't have said that. I should. There's so many things.
But we do collect GPS data from external
Yes.
devices. So we
Yeah.
do already have a few
native.
a few ways to get data in from other instruments, but it's the case of no, you have to trial each one and see. Some of them will either just work and others will take longer.
We did design it as like an extensible platform with a plug-in architecture so that this is possible. But as Brian said, there's sort of an irreducible complexity here
So-
that each device that you want to add.
Join us so that
Yeah,
we can
let me
be
come up
remote.
here.
And the question was, can we integrate data from external devices like a spectrometer immediately?
Yeah, and what I was saying, we did design the platform as so it would be extensible, and it has a plug-in architecture so that we can plumb in new devices like that. The problem, as Brian mentioned, is that each device and often each manufacturer of each device. And we've looked at total stations a number of times and explored it in some depth, and each manufacturer has a different protocol. Some of the manufacturers, kudos to Sokia, are very willing to work with us and share their stuff. Other manufacturers who will remain
Super
nameless
secret channels.
are less so. So there is a certain amount of development. And so we've concentrated on devices where if we solve one thing, we get a lot of devices. So Bluetooth GPSs use the NMEA 0183 protocol, and we solve that once and we get all the Bluetooth GPSs. Bad Elf works particularly well. That's what we'd recommend right now. So it's a bit of a development effort for each one. We have some on our roadmap. Others would be a feature that we need partners or clients to sponsor.
So did we answer your question?
Yeah.
Excellent. We have a question from online. From an ecology standpoint, does this interact with other national database infrastructures like Atlas of Libya in Australia and TERM?
Sure, I can do it. So yes, and I think I can even say this as a yes without a star. Well, the small asterisk that the old system that we had, we did have ecologists using it often when ALA's own tool BioCollect wasn't flexible enough to handle the workflow that they were doing. And so they'd sort of escalate to us, and then we wrote an exporter that would deliver the data in a way that could be ingested into ALA. Essentially any target that we have a defined target for, Brian can write, the ETL, the procedure to extract data from our system, transform it, and load it into theirs. And now on the new system, we have two pathways for that. One is a conventional ETL, which is we export it. Often the target is a CSV in a particular format. I think I didn't check this before I came in. I think ALA works that way, that you can export a CSV in a particular format and then they can ingest it. So we can do an ETL like that. If there's a relational database and we knew the target, we could do an ETL that would target that. But our new system also has an API, so we can push data out. Other people can pull data in. That we've got more modern sort of programmatic approaches to that as well. So we aim to maintain maximum interoperability with other systems, and we know that people are going to be moving data to virtual research environments and domain-specific repositories, and that's absolutely a priority for us.
One thing we've found, however, is that there's a gulf between collection and publication. That no matter what data you collect, you're going to want to standardize it. Nothing's undergraduate proof, and you're going to want to clean it. And so while we have these capabilities for exports, we've focused on an analytic ready export as our first class export, because in 70 projects that we've done in FAIMS 2, no one went straight to repository. They all want to do something with their data, and it's that processed, interacted with data that is the research, the publishable research output, not the raw data that from our app.
Some of our more, longer term FAIMS 2 users got it down to where it was a couple of days of work, but nobody entirely, there's always something that they wanted to change at the end. often using a tool like Open Refine, where they say, you know, we didn't quite get this vocabulary right, and we need to update some of them or something. But they've almost gotten, you know, eliminated it, and the data that comes off is clean. But there's always been sort of a little bit that they wanted to do before submitting.
Excellent. We have a question for Penny. Thank you. One more. What will the payment structure look like for researchers wanting to use the platform? Will it be a one-off payment, ongoing subscription, and or convince our universities to pay an umbrella subscription?
Yes, all three. Well, no, not a one-off payment. So we'll have a 3-tier payment system. So or if you include, anyone can go online and play with the tool and create notebooks and do a trial. That will be always free. And then, of course, the open source platform can be used freely. We'll then have an individual subscription, a teams-based subscription, and then an enterprise or university subscription. The names of those may change depending on the requirements of the app stores that we'll be publishing through. So our hope here at ANU and at many Australian universities is that we will be able to convince the powers that be to have an enterprise license that would cover either the whole institution or possibly a department, if so that the Teams tier is for 10 devices. For an individual user, it will be 2 devices. So that could be Android, iOS, or your desktop. And then in the enterprise level, we'll just need to negotiate because there's so much variation. Yeah. We expect a lot of institutions will want to manage their own hardware, so we'll need to work out some of that sort of thing. So the sort of short-term approaches would be starting as an individual, just to play around. A lot of PhD researchers or individual researchers only ever use 2 devices, so that would work well for them. The next step up would be for a department to take on a license and get 10 devices
that they can swap around. So it's like think about it is you 10 in the field at the same time, and so they can move from student to student, device to device.
Yeah.
And we.
I just to say these numbers are provisional too, but we're gravitating towards 2, 10 unlimited, and we're gravitating towards doing, all right,
lots,
lots, negotiate with it, and we're gravitating towards device-based because we think it introduces the fewest perverse incentives to do things like share logins, which mess up your data provenance, who did what to the data when. Or strict like data size limits, because we don't want you taking low quality photos to try to save some money, on storage. So, we're trying to avoid on an enterprise agreement, there might be limits unless the organization is running their own servers, or arranging their own servers on, say, AWS or something. We negotiate whatever the limits were, but we don't want to put like upfront limits on data sizes, because it makes people do things that compromise the quality of the data.
And the one thing you're usually sure about when you go into the field is how many devices you have. So it's actually, for field work, it's a good way to measure use. You're going to preload your set number of devices. So that's how we're basing our pricing tier.
So would you recommend this platform for a citizen science type of project, or?
Not yet, not for citizen science. So the question was, would we recommend this for citizen science projects? We have a fair amount of hardening to do before we're sort of ready to hand it over to the average user. It's we've run out of time for a demo. That's so dreadful. It's still a very complex system to navigate, and there's quite a few things we'll need to do to make it so simple that an untrained person can pick it up and jump in. That's definitely on our roadmap, though, because we do get a lot of questions about it.
Yeah, and it's definitely a core that we intend to do citizen science. It's on our roadmap.
We look forward to collaborating with a large project to achieve this goal.
So we're just hitting the time limit, but are people still interested to see a demo? We can do it quickly.
Excellent. So we'll just do this as part of the recorded thing, and then for the folks here, we'll do a much more entailed when we're off Zoom. And I don't see any more questions that have come through. So here you can see our auto incrementer setup. One thing that we have decided is that numbering systems are hard. and trying to account for record numbering across multiple offline devices is best done by the project director. And so the most common solution that we found is assign ranges to records. And so you will have 1 to 100, you will have 200 to 300, you will have 500 to 600. And we let the human organization handle allocation. And so we have these auto incrementers. And so here you can see that we are collecting, and so this is our 2014 through now Cyro minerals and resources geochemistry sampling. So they're collecting water samples, soil samples, vegetation samples, and rock samples. And actually,
Just a quick interruption. So this is the browser version of it. Obviously, it looks different, renders differently on a smaller device.
Yeah, I mean, it renders much the same on a smaller device, but is designed. It is usable on my phone without needing to be in surreal landscape mode. And so here, oops, here you can see water sampling. And so the other thing that we do is we have drafts so that you're never going to lose data. I mean, you might lose a second or two, but even if you have to back out or swap screens, it's always saving drafts in the background. And then once you're sure and you're done with things, you can say publish. And that's when it is set to be shared with other devices when you return online. And so here you can see that we have metadata. So ANU, station, vendor area 1, site name, coffee, because there's something on my mind right now. And so the other thing that you will note is that we have a composed human readable ID. One of the things that caused archaeologists to storm out of the room in high dudgeon was agreeing on a naming convention, because they're all special and they're all correct and they're all different.
Mm-hmm.
And they remain so.
Yes, they remain.
And so what we've decided is that we bow pure wisdom, and we are able to compose identifiers from 0 or more fields in the records with whatever static text you want in the middle of it. And so here we have ANU pulled from campaign label, -W-, because they need to be reminded that it's a water sample, with our auto incrementer.
A lot of projects had very esoteric naming conventions that encode a lot of information into this label. This is a legacy of doing things on paper forms and in notebooks, and we try to move people away from encoding information into the labels. It's like the information's in the record, don't encode. It's the same principle behind persistent identifiers, like an ORCID or a DOI. The number is just a number. It doesn't mean anything other than a DOI has got a particular prefix that says it's a DOI, but otherwise it doesn't mean anything. And we try to move people, but wow, people are attached to their identifiers. And
it
so
was a deal breaker.
We for a while were writing very complex scripts to say, okay, what site are you at? What sector are you in? What trench are you there? And now I'm going to go read all of the existing records and try to automatically apply. And this just didn't work, especially since we're offline, right? And we round up with conflicts. So we have now used the expedient of auto-generate a sequential number and grab information from the record and compose a human readable identifier.
And so so here you will note that we have annotations. So in case you need to scribble in the margins of your campaign, we can. And this is what we mean, is that our annotations, because we have online people, are attached to but distinct from your data, so that when you're collecting your data, your notes in the margin don't have to be cleaned after the fact. They're in their own column, but they're linked appropriately.
So, and so if anyone wants to talk more about this later, I'm happy to, but I'm quite interested in fair data and like reusable data. And I'm working on a paper now with some of I've got a comment to the ARDC right now with some of my colleagues, input from them about, how to make data as fair as possible from the very beginning. And I want to leverage, for example, this annotation capacity to put in a more structured kind of annotation about what kind of metadata should you be capturing here. And much of that, the device captures automatically and the software captures automatically, but we want to leverage this to do more with, getting very granular metadata.
So you'll note a time-saving thing that we have here are persistent fields, so that you're not entering the same thing in the same record for 3 days straight, because it's the same campaign, it's the same station. And so that's a major quality of life thing. And so here I'm showing how we have subsamples that I was speaking about earlier. And so we can say what our pH is. I'm not a chemist, so I'm going to choose numbers. These numbers are numbers. They don't mean anything. They might not even be valid. And here it automatically captures the timestamp of the sample. And if you're running a little bit late, you can say, no, now. And it'll update that. So you actually have very fine granularity of your subsample collection. And you will note that this is my preferred pH, and it adds a string preferred to the label so that when you're done, and so yes, this means that our labels can be intelligent and actually add to themselves based on the presence or absence of data. When you're done, you can see all of your subsamples in your parent sample, because this is what your data looks like, and we obey your requirements, not ours. Geo, so it's part of the same thing. Now, in this case, our accuracy is 1 kilometer, so don't rely on this data because there's no GPS on this device, so it's using Wi-Fi, but it gives you all of your data. And then
And metadata where it's available, like GPS metadata,
Yeah.
accuracy, for example.
I don't know what happens when I push this button with Zoom running. Yeah, so right now Zoom's using the camera, but we will have a lovely
That might have been a mistake.
that was a mistake. Don't collect photos while doing a web presentation. Okay, I'm going to let that be the hint that we should call this to an end. We also have hierarchical data, and we have many other data types. And to those of you online, email us at info@faims.edu.au, and we're happy to run demos for you folks. And for those of you who are here, apply us with coffee, and we're happy to run demos for you as well. Yes, so it just took a while. Excellent. So now I can hit save. And so the thing that I wanted to conclude on is our hierarchical metadata is pulled from controlled vocabularies published by CSIRO and published by the ARDC, so that your data on export is consistent with other people's data on export. Amazing.
Yeah, so this was the problem before. We could never get people to themselves link to these controlled vocabularies. So now we've got a provision to just import the.
Here's what I was talking about, how when you give people an opportunity to take a photo, they go, oh, wait, we could have labeled photos. And that's how it does that. I see no further questions from online. Thank you all for having us here on your lovely campus. We'll hopefully be back soon.